Normal distribution, which is the most important concept of statistics. Before we start that, I just want to confirm, I just want to explain one more thing in detail or in depth. So that's again the CI, confidence interval. So, of course, what we are really interested in when we have a sample result is when we have a sample result, we are very much interested in asking question, what is the probability that the true value lies within a certain interval. That's what we are very much interested. But this is not really the question that a confidence interval answers. So, but this is not a question that a confidence interval answers. Then what is the question that it answers? But it ends up being how most people interpret the answer. So the probability question associated with a confidence interval starts out with the phrase, this is what the actual question, phrase that given a sample, this is what the actual question, given a sampling procedure, this is what is the actual one, procedure and a population, given a sampling procedure and population, what is the probability that, and goes on. So to go in the opposite direction, so given a sample result, what is the probability that something is true about the population? This is what the exact question. What is the probability that the number of seats, number of seats win by, number of seats win by BJP? That's what. So given a sampling procedure and population, what's the probability that number of seats win by BJP? So this involves more complex calculations and deeper imponderables. But anyway, at least if you're clear about this, that's more than enough. This is the advanced way of understanding. But at the end of the day, it doesn't matter. I just want to give you some explanation, that's it. At the end of the day, if you are able to interpret a confidence interval at least in this way, that is also fine. Okay, now let's get back to the normal distribution. So what is a normal distribution? The bell-shaped normal distribution is iconic in traditional statistics. The fact that distributions of sample statistic are often normally shaped has made it a powerful tool in the development of mathematical formulas that approximate those distributions. Okay, let me explain about normal distribution in detail. But before we understand what is normal distribution and each thing, I just want to explain the historical aspect of normal distribution also. So just listen to me for few seconds, then we will get into the actual understanding of normal distribution. The normal distribution, also known as the Gaussian distribution, was not discovered, basically it was invented. So it was it emerged simply. If you say that it was emerged as a mathematical concept that could explain and model many real world phenomena. So the concept of the normal distribution can be traced back to the 18th century when mathematicians such as Abraham de Moivre and Pierre Simon Laplace. I think most of the engineers, if you are from mechanical engineer or if you have done your statistics in bachelor's of engineering or if you have done your masters in mathematics, you would have heard about Laplace. Even if not, if you are an engineer, you would have heard about the Laplace. So Pierre Simon Laplace studied the properties of the sum of a large number of independent random variables. They observed that in many cases the distribution of the sum appeared to be bell shaped and symmetrical. So, this led Laplace to propose a mathematical formula for this distribution, which became known as the normal distribution. So the normal distribution gained widespread use in the 19th century when it was used to model errors in the astronomical observations and other physical measurements. In the 20th century, it became a cornerstone of statistical theory and a fundamental tool in the fields such as engineering, economics, and social sciences. The normal distribution is particularly useful because it has many properties that make it easy to work mathematically. So it's fully characterized by just two parameters. One, its mean that you can see on the screen. I put it on the screen. One is mean, that's here, and the second one is the standard deviation that you can see here. So mean and standard deviation, so which make it easy to describe and compare different data sets. Additionally, many real world phenomena naturally follow a normal distribution or can be approximated by one, making it a useful tool for modeling and analysis. So that's what the historical presence of a normal distribution curve. So, and one more thing, I just want to make sure that it's a common misconception that the normal distribution is called that because most data follows a normal distribution. So that is it's the normal thing, but most of the variables used in a typical data science project, in fact, most raw data as a whole are not normally distributed. They would be long tail distributed. So the utility of the normal distribution derives from the fact that many statistics are normally distributed in their sampling distribution. Even so, assumptions of normality are generally last resort used when empirical probability distributions or bootstrap distributions are not available. So that's what the complete history and then present condition of the normal distribution. So now we will look into the normal distribution step by step. So as I have told you before, the normal distribution, also known as the Gaussian distribution, is a continuous probability distribution that you can clearly see. What you see on the screen is 0.1 percentage, 2.1 percentage, 13.6 percentage, 34.1 percentage, and then again it repeats, and at the center 50 percentage. What is this? This is probability. That what you see on x-axis is a probability, and on sorry, absolutely sorry, what you see on y-axis is the probability, and what you see on x-axis is your mean and then standard deviation. Okay, so obviously uh, it's a continuous probability distribution that is widely used in statistics and other fields to model a wide range of natural phenomena. It's a bell-shaped distribution that's symmetric around its mean. You see that this is the mean. It would be symmetric around its mean, which is also its a median, which is also a mode of it. So mean, median, mode all stay at one point. That's what we have written in the second point. So let's look into some of the features of this. The first one, the total area under this curve is equal to 1. First point. Second, the mean, the median, and the mode of the distribution are all equal and located at the center of the curve, at the center of the curve. Then the distribution is symmetrical around its mean with 50% of data falling on either side of the mean, either side of the mean, positive side and then negative side, or left side and or right side. So the standard deviation that you can see here, the standard deviation determines the width of the curve. The larger the standard deviation, the wider of the curve. The smaller the standard deviation, the thinner of the curve, or the narrower of the curve. So the normal distribution is widely used in statistical inference and hypothesis testing, as many natural phenomena follow a normal distribution or can be approximated by one. So in what all fields we use normal distribution, that I will explain. But before that, there is one more most important concept is there under this that I will explain. That in normal distribution, the data falls within certain range depending on the number of standard deviation from the mean. So the specific proportion of data that fall within each range can be calculated using the empirical rule, also known as 68. This one is 68, 95, this yellow portion 95, and then 99.7, 99.7. I am repeating again, the rule, the empirical rule name is 68 at the center, 95 here, and 99.7. So this is what is called the empirical rule. Based on that, we can get to know how much of data falls within which range. So according to this empirical rule, that is 68, 95, 99.7 rule, approximately 68% of the data falls within one standard deviation. How much is that? 68.2 percentage or 68 percentage. You see that this is the mean, this is the one standard deviation plus and one standard deviation minus, and in between how much of data is falling? 68.2 percentage. 68.2 percentage of the data is falling. Okay, that's what is the first rule, empirical rule. Then after that, you got the 95 percentage. That's approximately 95 percentage of the data falls within two standard deviations. So standard deviation 2 positive, standard deviation 2 negative. So in between how much data is falling? 13.6 plus 34.1 percentage multiplied by 2, that is equals to 95 percentage of the data is falling within this. That's why normally we take 95 percentage of confidence interval. So now initially you know what is confidence interval, what is 95 percentage of confidence interval. Now I'm putting these things on the graph. We need some mathematical notation. So from where we get it, all those things, how would we understand that? Okay, 95 times, if you repeat the same procedure, still your real value will be in that interval, in that confident interval. How would we know that? Using these curves, using these curves. If that sampling distribution approaching the normal distribution curve, then only that works. If it is not so, it may not work, it won't work. I hope you got my point. So this is a second standard deviation, and 95% of the data false. And after that, you have the most important one, that's approximately 99.7%. That means most of the data falls here. Most of the data within three standard deviations of the mean. So 3 sigma and minus 3 sigma. So within this three standard deviations of the mean, so most of the data false. That's equivalent to even 99.7% of data falls here in this. So this means that for a normal distribution, the majority of the data is clustered around the mean, and the further away from the mean the data falls, the less likely it's to occur. So for example, uh, if a normal distribution has a mean of 50, let's take here the mean is 50 at the center, and the standard deviation of 10. So then I will have here, I'll have the value 50 and standard deviation of 10, and then 20, and then 30, same, minus 10, minus 20, minus 30. So now approximately 68 percentage of the data will fall between 50 plus 110 and 50 plus 50 minus 110. So total 50. So in between 40 to 60. So a 68.2 percentage of the data falls if and only if the distribution, whether it is sampling distribution, if the sampling distribution, if it is in the shape of the normal curve, then only these rules are applicable. If not, no rules are applicable. Simple, pretty straightforward. Okay. So now, okay, so that's 40 and 60. Approximately 95 percentage of the data will fall between 50 plus 20 and 50 minus 20. That's 30 and 70. And approximately 70 percentage of the, sorry, 99.7 percentage of the data will fall between 50 minus 30 and 50 plus 30. That's in between 20 and 80. So understanding the proportion of the data falls within each standard deviation from the mean is important for statistical analysis and hypothesis testing, so as it can help determine whether an observation is unusual or falls within expected range of values for a given distribution. So now let's wrap up this after looking into the various fields where this normal distribution is applicable. Okay, let me write down. So this is normal distribution. It's just a normal distribution. So application one, it's many natural phenomena follow normal distribution, so or it can be approximated by one. So it's also used in the most important one, quality control. Now the data science came, but from the years, from the decades, they are using this sigma in quality control, and they are having the concept called six sigma. Six sigma. So we have only 3 sigma here, but some companies has gone to such extent they have 3 sigma, 4 sigma, 5 sigma, 6 sigma, so that they can reduce the damaged components, reduce the damaged components to be delivered to the customers. So that's how this normal distribution is bringing a huge difference in the lives of quality control employees. And then 2, finance is very important. 3, engineering, of course, every level of engineering, and many other fields where the distribution of the data is important to understand and model.